Okay, before we end up, because we already finished describing the backpropagation mechanisms, I just show you how actually we derive from the simple neural network, and then we managed to generalize it into these algorithms, and you find out, you realize that this generalized algorithm can be used in many ANN architecture. If you change the architecture, you still can use the same algorithm. Just this one is just a basic one, it's not advanced, so that's why there's no stopping criteria there. So that's why it will repeat the step 7 up until how many number of epoch that do you want to do. So if you set the epoch equal to 1000, it will repeat the same process 1000 times, means that one epoch is equal to 100. If you talk about, if your data set number of your data set is 100. Okay, okay, you might realize that, like I discussed in previously, okay, if you have 100 sample in your data set, means that you need to repeat step 2 to step 500 times. Means that each time you execute step 2 to step 5, you will calculate the weight or the updater of your W and your B, and then you update your W and your B. Okay, each time you execute step 2 to step 5, you will update your W. Means that one sample, once you feed one sample training data, by executing step 2 to step 5, you will update your W and your B. So I want to relate this one with the previous note that you have, I think you have learned before, which is this one. Yep, this one. So you can see that my algorithm here, if I feed a sample of data, or sample of training data, or single sample of training data, I will update my W and B. So if you review the previous note, if I update my my update parameter is depend on a single training sample, that is called a stochastic gradient descent. Okay, so this algorithm, what I discussed in this general step, actually is a stochastic gradient descent. Okay, so why my derivation end up the general algorithm end up with the produced algorithm, which is executing the stochastic gradient descent approach. Why is not using why is not end up to the batch gradient descent like the one that you learned in this slide? Because in this slide you end up as a batch gradient descent, but during my slide you see that my general algorithm here, when I update my W, is called a stochastic gradient descent. Okay, can you relate this with this slide and this slide? I'm sorry. So my example, I end up as a stochastic gradient descent, but this slide you end up as a batch gradient descent. Means that you updating your weight of your theta based on a batch. Means that after you get all 100 error from your I mean, when let's say your data set number of sample in your data set is 100, you will update your theta after you execute the error of all 100 data. But mine, each and every sample I will update my W and B. So means that my example, I end up to what we call as a stochastic gradient descent, but the previous slide, this slide is end up into producing this algorithm, which is batch gradient descent. So why is that happen? That is because, again, at the beginning I already mentioned to you the definition of my E there. Sorry. Okay, my E there is not the error there is the total error there, E. Okay, if you go back to the first slide, let me go to the first slide there. Yep, you can also use this slide. Widget, this one. Here, sorry. Okay, here, I think I already mentioned to you, I'm using SSE, sum square error. Means that I just count a error which is produce the difference between a single sample. The previous lecture, which is the linear model for regression or for classification, you are not using the SSE, you are using the MSE. Okay, if my example I'm using MSE, now my E there doesn't matter E1 or E2, again E1 or E2. Okay, I just put it, if I want to apply my MSE to the E2, the definition of E2 is 1 over 2n. Okay, and then you have a summation of I equal to 1. Let's say my data set, the number of data set is 100. So from I from 1 to 100, then my Y 2I minus Y hit 2I square. So this is MSE. But because I'm not using MSE, I'm using SSE, which is this one. So that's why I end up my algorithm as a stochastic gradient descent. But if I'm using MSE to define my E1 and E2, then that will make my algorithm becomes batch gradient descent. Okay, so that is just that is different between this one and the previous lecture regarding the linear model for regression or classification. Okay, so meanings that if I using the batch gradient descent, okay, this is another thing that you need to make sure that you know, is that okay, what is the difference if I'm using MSE? So if I using MSE, what happened to this step? Which one is need to be need to be modified? Of course, at this step, okay, because this one is the one that defined by SSE. Okay, if I'm using MSE, then my EM should equal to, yeah, what is my EM there? Of course, then you need to put there is 1 over n summation of my Y hit 1 minus Y, I'm sorry, it's not, it's I here, Y I here. Okay, you should be something like this. Okay, it's a summation. because now because the E here is the definition of E here is based on single sample, so that's why it become SSE. So if you want to compute the in term of MSE, then this one is should be, you will have a summations there, and then means that you are repeating 100 times to compute, and then one you get the average of this difference, that is will define your E. Once you find your E, then you will update your delta here. So from there you can see that it's a little bit difference in terms of the definition of epoch and iteration. Remember that in this example, in SSE example, the previous one, when you have 100 data, one epoch is equal, the iteration is one epoch, you have 100 iteration. Okay, that is because at the means that what is the 100 iterations here, you are updating 100 times for each epoch. But if you talk about if you implement the MSE, it will become one epoch, the iteration is only one iteration, and means that you will only update one times update, because after 100 time you complete one epoch here. Still the definition is similar. One epoch is once you complete a full cycle where you utilize each and every sample inside your data set. Because your data set is 100, the number of data sets is 100, then one epoch to apply, if you apply the MSE, your E here is the average of after you complete 100 samples. So that means the iteration here is only one iteration. Okay, 100 epoch, one iteration, and then you update only one time update. But for SSE, each time you take one sample of training data, you will update the W and B. So means that once you repeat 100 times to utilize all your sample inside your data set, you will update 100 times. So that is what is mean by stochastic gradient descent. And then the one that you used before during the linear lecture of linear model for regression and classification, because you are using MSE, the iteration, one iteration is equal to one epoch, because one iteration, what is meaning by one iteration is one, this is the one that the number of time that you update your W. If your iteration is 100, you will update 100 times. If your iteration is 1, you update 1 time. So means that when you using SSE, you will end up as a stochastic gradient descent. But when you are using batch gradient, I'm sorry, when you are using MSE, we will end up as a batch gradient descent. Okay, so that will that is the explanation in discussing this thing. Okay, but because previously we start the when we want to derive the algorithm, we start using MSE. That's why you end up as a batch gradient descent. But when I'm using during the neural network lecture, I'm using a SSE, I end up as a stochastic gradient descent. Means that one sample you update the parameter, another sample you update the parameter. But this one, after you complete 100 number of data sets there, then you update the W. So means that you only update once per 100, and then you, of course, you will repeat the process again. Once you set your epoch equal to 1000, means that you update 1000 times. Here in stochastic gradient descent, if you set epoch equal to 1000, one epoch equal to 100, meaning that you are updating your W and B at 1000 times 100 times. Okay, of course this one the advantage of this one is can reach a minimum faster than batch gradient descent, because this one because you bunch, you get one batch. Once you get one batch error, then the error represent the average error of everything's there. That's why the to converge is a little bit slow as compared to stochastic gradient descents. And then I think this one have been discussed. This one is actually is a intermediate. Is a intermediate. I mean, it's at the center there. It's a middle between this one and this one. Means that at the mini batch gradient descent is one they because they want to tackle, or because this one have some disadvantage. This also have their own disadvantage. So by introduced with mini batch gradient descent, it will complement between this one and this one each other. So that's why they introduced with mini batch gradient descent. So in mini batch gradient descent, it is something where actually this the third one, which is this one, mini batch gradient descent, is popular when later when you learn about the deep learning, especially convolutional neural network. This one is the most popular one because you have a big parameter, huge number of parameter of W and B, and you see that the best technique in converge the function is by using the mini batch gradient descent, which is actually a combination between stochastic and batch gradient descents. Okay, so in mini batch gradient descent, what is they do is actually, let's say this is your for example, this is your data. Of course, the total number of your data is 100. They separate your data into small batch there. That's what we call as a mini batch. For example, I separate this one into, let's say, 5 batch. Means that each batch have 20 number of samples. Okay, I divide it into 5 batch. So what actually the mini batch gradient descent do is that they take the first 20. Okay, this, for example, I take this first 20, and then I try to find the average error there. Means that from this 20 data, so means that from 1 to 20, I calculate the errors there. Okay, I calculate the errors, and then from that error, that is my E. Once I get the E, then I update. I find my delta. For my delta, I try to find my updater W and updater B, and then meanings that for each mini batch you will update your W and B. Then the next mini batch you again update your W and B. So meanings that in one epoch you have how many iteration? 1, 2, 3, 4, 5 iteration. Okay, so that is a mini batch gradient descent. One epoch you will have 5 iteration. So 5 iteration represent 5 time update your W and B. So this one is actually complement the advantage of and disadvantage of stochastic gradient descent and batch gradient descent, because they formulate in such a way is look like a small batch. When you talk about many batch, it seems to be a combination or hybrid between batch gradient descent and stochastic gradient descent in producing this what we call as a mini batch gradient descent. So that is later this is the best technique in especially in the latest deep learning algorithm. They use a mini batch gradient descent as compared to gradient descent, static gradient descent or batch gradient descent.